Hi everyone, welcome back to our notes. This is 8.1 today. We are starting a new unit and we are going to talk about similar polygons. So let's talk about some vocab here. Similar figures are basically figures or shapes that have the same shape. So same shape, but not necessarily the same size. So same shape, not necessarily the same size. A similarity transformation can be a dilation or a composition of rigid, so I can spell that, motions and dilations. And then corresponding parts are pairs of sides or angles with the same relative position. So we've done that one before, so I'm not going to write that. That was back from earlier this year. So again, sides or angles with the same relative position. Let's talk about this idea of corresponding parts of similar polygons. There's two parts here. First of all, I want you to notice, I guess I'll read this. It says, in the diagram below, triangle ABC is similar to DEF. You can write ABC as similar to triangle DEF as, and here's the symbol, triangle symbol ABC. And notice now we have a similarity symbol, which looks like a congruent symbol without the equal sign. So similar is that symbol right there. That means similar to. Right, a similarity transformation preserves angle measure. So the corresponding angles are congruent. So that's this part right here. Corresponding angles are congruent. A similarity transformation also enlarges or reduces side lengths by a scale factor. So the ratio, which means a fraction of the corresponding side lengths, all have the same scale factor. So I'm going to quickly highlight something here. If I look at DE, it corresponds with AB. Their ratio is going to be the same as EF's ratio with BC. And then the same thing with that third side. Next, we have this third side. If we look at their ratio, they're all going to be the same. And it just so happens that that is going to be what's known as your scale factor. Now, when you are writing a scale factor, what happens is you have to look at which direction are we going. So we have a starting shape and we have an ending shape. You have to look, is the ending shape bigger or smaller? And whatever happens for your scale factor, where you end is always being divided by where you begin. Sort of like your CP prime divided by CP that we had going on. All right, let's go to the next page. There we go. All right, corresponding lengths in similar polygons. It says if two polygons are similar, then the ratio of any two corresponding lengths in the polygon is equal to the scale factor of the similar polygons. Basically what we just had right before this. So let's talk about some theorems. Perimeters. If two polygons are similar, the ratio of the perimeters is equal to the ratio of the corresponding sides. So basically, the ratio for the perimeters is going to be the same as the sides or also the normal scale factor. So basically, let's say perimeters is the same as the scale factor. Hopes if I can write that. Scale factor. Sorry, I'm a little sloppy in this writing today. Where area, if you want to look at the area here, the ratio of their areas, the area is your original ratio squared, or your scale factor squared. So let's just get this into some, let's use this. Example, extra practice one. Let's look here. We have two rectangles based on the shapes that we see in this picture here. And what we can look at is, let's find the value of x. So remember, it is the idea of the corresponding sides ratio. So let's look at two corresponding sides. I have my x side here, which is the long side of my rectangle, and my long side here is 7. So I'm going to set up what's called a proportion. I'm going to write x over 7. Now from the same triangle, from my x, I want to look at another number, which is 2, and it corresponds with 3. So I'm going to say equals 2 over 3. Notice what I have here is I'm going to put the same shape in the numerator and the same shape in the denominator, and one fraction is showing the corresponding parts. Now to solve this, we have a simple one-step equation. Multiply both sides by 7 here, and I get that x equals 14 thirds. Now, depending on how you have these set up, we can do some other cross multiplying. I will typically like to have my x on top. I'm going to show you what happens if you put your x on the bottom. So in this question here, I want to find my x. My x here is on this side between the 1 arc mark and 3 arc marks. Between 1 and 3 is 25 here. So some students will prefer to go left shape first, right shape second. So they might say 25 over x, those are my corresponding sides, is equal to, and now we're going to find two other ones. 1 arc mark and 2 arc marks is 20. Between 1 and 2 here is 8. So then I would write 20 over 8. Now, when your x is in the denominator, we are going to have to cross multiply and then divide. So 8 times 25 will give me, what is that, 200. X times 20 would be 20x. And when I divide, I'm going to get the x equals 10. All right, last section here. Find the scale factor. Notice this says from A, B, C, D, E to K, L, M, N, P. So we are going from A to K. We're going from that shape to there. So what we do is you look at the numbers. Remember what we said earlier. You take where you end and divide where you begin. And this helps because my scale factor should match. In this case, I'm going from a small shape to a larger shape, so my scale factor should be something larger than 1. So I'm going to look at two corresponding sides. I might look at 3 and 2 and just say where I end is 3, where I begin is 2. Does that simplify? Notice my scale factor is 3/2. On number 4, we're wanting to go the opposite direction. So if I want to go the opposite direction, now I'm going to end with 2 and start with 3. So that would be a 2/3 scale factor because I'm getting smaller. So if we wanted to solve this, we get to set up some proportions. It's probably one of the easiest ways. So here's what we're going to do. I'm going to use that scale factor as a proportion. And it says find the values of x, y, and z. So let's find x real quickly here. X are these shapes right here. I want to see what x corresponds with. X corresponds with 1. So here's what I'm going to do. I'm going to say x over 1 equals, and again, I'm going to look at my corresponding part in this triangle, which is 3. So I'm going to put my 3 in the numerator, and but not my denominator is going to be the same number that's in the shape of my 1, which is 2. Now in this case, if I want to solve for x, I multiply both sides by 1, and I just get 3/2. Pretty easy, or known as 1.5. Now, if I want y, so let's look at y here. Y is right here. So my y compared to 3 square root 2 is equal to, and again, I'm going to look at what I had originally, 3/2. So let's cross multiply. Actually, not cross multiply. Let's just multiply each side by 3 square roots of 2. So I'm going to get 3 times 3 square roots of 2. And I'm going to get that y equals 9 square roots of 2/2. Now we need to find z. So here's z. Where is z located? Z is right here. Now remember, angles have their measurement preserved. So that corresponds with angle K, which is just going to give us 45 degrees. There is no scale factor with your angles. All right, perimeter of each polygon. So what happens, I can look at my first polygon here, right here, and I can add all these together. 2 plus 1 plus 1 plus 2, and that's going to give me 6. So the first one, A, B, C, D, E, A, B, C, D, E, that one's perimeter is going to be 6 plus that extra 3 square roots of 2. Now, if I want to find K, KLMNP, what I can do is look at my scale factor now. So I'm going to do a little bit of erasing to not take up too much extra space here. So if I'm going to look at KLMNP, I'm going to take, now notice if I want to go from my small shape, which is A, B, C, D, E, to KLMNP, this up here in questions 3, so if I go from the smaller to the bigger, I'm going to have a scale factor of 3/2. So I'm going to take 3/2 times 6 plus 3 square root 2, and that's going to give me my scale factor here, which is 9 plus 9/2 square root 2. And that would be for KLMNP. That'd be my perimeter. Now, ratio of perimeter. Notice it says 2. So I'm going from ABCDE to KLMNP. And from our theorem that we had, it's the same as its scale factor. So notice direction. I want to find my scale factor as the same direction, which is our question number 3. So that will be 3/2. Now for number 8, same direction, A, B, C, D, E, to K, L, M, N, P, but the area of similar polygons theorem says you need to take that scale factor and square it, which will be 9/4. That would be the ratio of the areas. All right, there's your lesson. If you have any questions, reach out. If not, we'll see you in the next set of notes or in class. Have a great day.